Here, I'll show you how subtraction looks like. And again, much like regular base 10, subtraction is more or less the same. The numbers highlighted in yellow here are the base 10 equivalents of these hexadecimal numbers. So 5 minus 4 is just 1. There's nothing else to subtract here, so we bring down the 1. 21 minus 4 is going to be 17. So we can check this to see if it's correct. 1 times 16 raised to 0, and 1 times 16 raised to 1. 16 raised to 0 is just 1. 1 times 1 is 1. 1 times 16 raised to 1 is just 16. 16 plus 1 is equals to 17. So that's true. 26 minus 5. So 6 minus 5 is just 1. Nothing else to subtract 2 by, so we bring down 2. So we have 2, 1. So that's 38 minus 5. 38 minus 5 is just 33. So let's check that. 1 times 16 raised to 0 and 2 times 16 raised to 1. 1 times 16 raised to 0 is just going to be 1. And 2 times 16 is going to be 32. 32 plus 1 is 33. So that's correct. Now what if we have a number here that's larger than the digit trying to subtract it by? Because 1, 3. 3 minus 8, that's too large. So, much like in regular addition, if we have a number that's too large to be subtracted by, we would borrow from the left side. Right, we borrow 10 from the left side, so 16 minus 7. It's a weird question, but we all know that this is 9. Anyway, so we borrow from the left side. So our 1 is going to be 0 now. But instead of adding 10 to 3 and becoming 13, we actually add 16 to 3. So 16 and 3 is 19. And we know that 8 minus 19 is just going to be 11. So we write B. Why B? Because B is equals to 11 in hexadecimal. So that's correct. Now we can also just check this to see if we are correct. So that's going to be B, or 11 times 16 raised to 0. That's just going to be 11 times 1. So 11. As you can see, 19 minus 8. Sorry about that. 19 minus 8 is just going to be 11, so that's correct. I'll show you the rule more on that in the next example. Note, much like in base 10 subtraction, we would borrow a 10 from the left digit and then subtract 1 from the left digit as we borrow, and then we add that 10 to the current minuend. But in hexadecimal, we borrow 16 instead of 10. If you're not familiar with terms, I'll just show you what I mean. If you have a number like, let's say, 25, and then you want to subtract 9 from that, you can't really subtract 5 and 9. So what you do is you borrow from the leftmost digit, you subtract 1, so the 2 becomes a 1, and then you add the 10 to the current minuend, which is 5. So 10 plus 5 is 15. 15 minus 9 is 6. So we just bring down the 1 there, and then we get 16, right? So much like in hexadecimal, we do the same, except we borrow 16. So I'll show you there. A minus D can't be, right? Because D is 13 and A is 10. So we borrow from the left side. C now becomes a B because we subtract 1. C is 12. 12 minus 1 is 11, and B is 11. So now our A here becomes a 10 plus 16, which is 26. So I just write 26 here. I just choose to write it in decimal notation because it's easier to look at that way. So 26. 26 now. We can now subtract that by 13, right? So that just becomes 13 again. So we just bring down the D. And then B minus B is just 0. And then we don't really need to write that, so we just don't mind that. So D is 13. And here in yellow, I wrote that in decimal form, so we can just check that easier. 202 minus 189 Again, we just borrow, right? Comes 1, 9, and then 12. 12 minus 9, that's 3. 9 minus 8, that's 1. 1 minus 1 is 0, 13, right? Same number. This formula here is what I just used earlier. So 10 is equals to x minus 16. Add 16 to both sides, and then we get 26. So that's why the x here was 26. I just used this formula in my head. That's the rationale, the explanation behind it, if you're confused. You don't need to specifically use this, but I find it helpful for longer numbers when I'm getting confused. But over time, I'm sure you can do it mentally. So let's look at another example here. What if we have zeros? Again, much like in base 10, we would keep borrowing until we have a number that actually has a value. And instead of 9, right, because if we borrow a 1 from a 10, that's just going to become 9. If we borrow a 1 from a 16, that's going to become 15, or f, right? So I'll show you that. 0 minus d can't really subtract 0 and 13, so we just keep borrowing. We can't really borrow from 0, so we just keep borrowing. Now a can now become 9 because we borrow, because 10 is equal to a in hexadecimal. So 10 minus 1 is just 9. And now we can have this as 16, our 0. But remember, we also borrowed from this digit. So that becomes 15, or f. Now we can write the 16 here on our 0. So 16 minus d is 3. Now again, I'll explain to you here after we borrowed, right? So we get the 16 after we borrowed. So our minuend, right, our 0 is equals to x minus 16. So if we add 16 to both sides, we get 16 is equal to our x. So that's where the 16 came from, right? Pretty cool, yeah? So 16 minus d, which is 13, is 3, yep. F minus b, our f, remember, is equals to 15. And our b is equals to 11. So 15 minus 11, that's going to become 4. 9 doesn't really subtract with anything here. These digits are empty, so we can just bring down our 9, and then we can have our c here. And then we can check that. Maybe I'll use a different color so you guys can see. 51712 minus 189. We borrow, right? That's a 0. That becomes 12. That's a 3. We borrow again. That's 7 becomes a 6. Becomes a 2. It's a 5. And then we bring down the last two digits. That's 51523. And we can check that 16 raised to 0, 4 times 16 raised to 1, 9 times 16 raised to 2, and c times 16 raised to 3. 16 is just 12. So let's check that. That's just going to become a 3. 4 times 16 is 64. 16 raised to 2 is 256 times 9. 2,304, right? And then 16 raised to 3, 4,096 times 12. That's 49,152. 49,152 plus 2,304 plus 64 plus 3. Let's add those together using my calculator. That's 3. And then we have 51,523. And as you see, it's the same answer. So here we have a little bit of a longer example with a lot more hexadecimal digits to be displayed. And here's that rule I was talking about in formula form. This formula here actually just converts our decimal number into hexadecimal for this digit. So an easier way of looking at this is to just look at them as 1 digits each, so you don't get confused. Anyway, let's get into it. A minus D. A is just 10, and D is 13. So 10 minus 13, that's a little too large. We can't really do that. So what we can do is get the minuend. The minuend is the number to be subtracted. So A, let's just write 10. 10 is equals to x minus 16. Now, to get rid of the 16 and just get x, we need to add 16 to both sides. So that's 26 is equals to x. So remember from earlier, we borrow from the left side. That's just subtracted by 1. So C subtracted by 1 is going to be B. So this is going to be 26. I like writing this in just decimal notation because it's easier to follow. 26 minus D is going to be D again because that's just 26 minus 13. So we write D here. B minus B is going to be 0 because 11 minus 11 is 0. 7 minus 6 is going to be 1. And then 9 minus 5 is going to be 4. So the answer is going to be 410D, I'm sorry. And we can check if this is true here by just subtracting the hexadecimal form. Subtracting the decimal form, because I've written it here. So 8 minus 5, 3. 5 minus 0, 5. So that's going to be 2 6s, and that's going to be 1. So if we convert this, it should be the same answer there. So let's convert that real quick. D times 16 raised to 0, 0 times 16 raised to 1, 1 times 16 raised to 2, and 4 times 16 raised to 3. 16 raised to 0 is going to be 1, so that's just D times 1, which is 13. 0 times any number is 0. 1 times any number is the number, so 16 raised to 2 is 256. I'm using a calculator right now, but I don't think your professors will allow you to use one. 16 raised to 3 times 4 is 16,384. So 16,384 plus 256 plus 13 is 16,653. And as you can see, we have the same answer. So that's how you subtract in hexadecimal.